A mobile at the art museum has a 2 kilogram steel cat and 4 kilogram steel dog suspended from a lightweight cable, as shown in the figure. It is found out that theta 1 is 20 degrees when the center rope is adjusted to be perfectly horizontal. Okay, what are the tension and the angle of rope 3? Okay, so we need to find out the tension of the rope 3 here, but I think we need to find out all the tension in this rope, right? Okay, the first one, I think I will start analysis with this node here as our reference. And obviously we have the weight of the cat here, right? Pushing this down. So I will have the weight of the cat here. And then we have the tension of the rope. In this case, it is pushing this up, right? So we will have this one here, the tension of rope 1. This one will be T1. Good. But this is not exactly on the X or Y axis. We need to decompose it into X and Y component, right? And the easy one is this one here. So we will have T1 on this side here. But this one is theta 1. So this is the adjacent side. And this one is the hypotenuse. Adjacent and hypotenuse, that will be cosine. So I will have here, we will have T1 cosine of theta 1. Okay, and for this here, the y component, obviously we will have the sine 1, right? So I'll have T1 sine of theta 1. Good. And also we have another tension of the rope, which is pulling this to the right, which is the tension of rope number 2. Okay, so now let's do Newton's second law analysis. And I will start from this y-axis because we have the numerical values of this cat, right? So I will have sigma f on the y-axis here, and that will equal to the mass times acceleration also on the y-axis, but they are stationary, right? They are not moving. So I will have this one is equal to 0, and then the positive one is the one that is upward. So I will have T1 sine of theta 1, and then minus the weight of the cat. So I have weight of the cat here, and that will equal to 0. So we'll have T1 sine of theta, and that will equal to weight of the cat, that will be the mass of the cat multiplied by g. And then for T1 here, I can simply isolate that here. So I will have mass of the cat multiplied by g divided by sine of theta. Okay, so for T1 here, I will have the mass of the cat, that will be 2 kilogram. And then g is 9.8. And then sine of theta, this theta is theta 1, right? So I have theta 1, theta 1. Sine of theta, theta 1 is 20 degrees. So I'll have sine of 20 degrees. Good. So we'll have the tension of T1 here. Let's plug this into calculator. Okay, what is that? We will have 2 multiplied by 9.8 and then divided by sine of 20. And we will have this one as 57.31. 57.31, and the unit here will be in Newton. Good. And now all that we need to do is to again Newton's second law analysis, but on the x direction. Okay, now let's do the cat again, but on the x direction. So we will have sigma f, but this time on the x direction, and that will equal to the mass multiplied by acceleration also in the x direction, and this one will equal to 0 again because it is stationary. Then I will have this one T2 as the positive one, so I have T2 and then minus T1 cosine of theta 1. that is equal to 0, or we can isolate for T2 here. So I have T2 is equal to T1 cosine of theta 1. But then T1 is this value here, 57.31, and then cosine of theta 1, that will be 20 degrees. And so we will have T2 here is this number, right? So I will have this number multiplied by, oh no, let's just plug that in, 57.31 cosine of 20. And I will have 53.85. 53.85. And the unit here will be in Newton. Good. Okay, now let's do analysis, but this time on this dog, right? So we'll have the weight of the dog pushing this down. So I'll have weight of the dog. And I also have T2 here pushing this to the left, pulling this to the left. So I will have T2. Okay, and then we will have T3 here. That is this tension of this rope, which is T3, right? And I think we can have again decompose this. So I will have T3 cosine of theta in this side, T3 cosine of theta 2, no, theta 3. And then this one here is T3 sine of theta 3. So I have T3 sine of theta 3. Good. Now what can we do? I think we will start with this x side here. So let's do that. So we will have sigma f on the x direction for the dog, and that will equal to the mass times acceleration also in the x direction. And on the right hand side we will have this as 0 because of their stationary. And then for the positive side we will have T3 cosine of theta 3, and then minus T2, and that will equal to 0. So we will have T3 here cosine of theta 3, that will equal to T2, or we will have T3 cosine of theta 3, that will equal to 53.85. Okay, and I think let's save this as equation number 1 here. And then let's do analysis on the y-axis. So I have sigma f on the y-axis, and that will equal to the mass times acceleration also on the y-axis. Okay, and that will equal to 0 on the y-axis here. And then the sum of the force, we will have the T3 sine of theta 3 on the positive direction. And then on the negative one, we will have the weight of the dog, and that will equal to 0. And so we can isolate for T3 sine of theta, and that will equal to the mass of the dog multiplied by g. Okay, so we will have T3 sine of theta 3. And what is the mass of the dog? We will have 4 kilogram. Okay, and then g is 9.8. Okay, so we will have T3 sine of theta 3, that will equal to, I think we will have, is that 4 times 9.8. Okay, and we'll have 39.2. 39.2, and let's save this as equation number 2. Okay, so now I want to skip equation number 1 and equation number 2. And I think we need to clean up our slide and works on that. Okay, now we have two equations and two variables. We should be able to solve it, right? And I think the first thing that easier to solve is the theta 3. So we'll have this one here. Let's divide both of them. So I'll have T3 sine of theta 3 here divided by T3 cosine of theta 3, right? And then the numerator here is 39.2, and then the denominator here is 53.85. Right? Why this is easy? Because this one here, T3 will cancel out, and then sine and cosine here becomes tangent, right? So I'll have tangent theta 3. So we can isolate that for this one. So here I can use theta 3 here. I can find out theta 3. That will be inverse tangent. So I'll have tan inverse. And then this number here, 39.2 divided by 53.85. And the only way to calculate this is plug that into calculator and we will get our theta 3. So that will be shift inverse tangent, and then we will have 39.2 divided by 53.85. And that will be 36.05. So I have 36.05, and the unit here will be in degrees. So that is the angle, right? So we will have this one as our answer here, which is the angle of root 3. And then it is asking us for the tension. We can plug this into equation 1 or equation 2, which I will exactly do it. So I will have T3 sine theta. Remember that T3 sine theta is equal to 39.2. And so we can isolate that. T3 is equal to 39.2 divided by sine of theta 3. Right? But then theta 3 is this number here. So I have T3 is equal to 39.2 divided by sine of 36.05 degrees. Good. And the only way to get this is plugging this into calculator, right? So we will have 39.2 divided by sine of 36.05. And I will have 66.61. So I have 66.61, and the unit here will be in Newton, and that is the tension of the rope. Okay, and I think we have done this problem. Thank you for watching and see you in the next video. Bye bye.